Hey class! Over the last few days, we've been talking about what is chemistry and how does it relate to you. And today we're going to jump into chapter 2 titled Matter and Change. Specifically, we're going to cover section 1 today, which is titled Properties of Matter. So our leading question is, why are windows made of glass? In this lesson, you will learn how properties can be used to classify and identify matter. What you observe when you look at a particular sample of matter is its properties. Basically, anything you can use to describe matter, whether it is qualitative information like descriptions or quantitative information with numbers, we are describing a set of properties. For example, is it solid, shiny, or dull? Does the liquid flow quickly or slowly? Is the gas odorless or does it have a smell? Glass is often used to make windows, while copper is often used to make electrical wires. So what properties of glass make it a desirable use for windows? I want you to try to pause this video and see if you can figure out yourself why we tend to use it. Now hopefully you've had some time to brainstorm. One thing you should know is glass, what makes it so great is that it is clear. We can see through glass. It is also very durable under temperature changes. For example, glasses work really well when it's winter and also works really well when it's hot outside. The other thing is that with glass, while it is easily able to break if something is thrown at it, it does have that durability for the most part, especially if they mix it with other elements. So those are two big things of why we use glass in our houses. Now, properties can be used to describe matter, can be classified several different ways. The first two ways that we're going to classify properties is whether the property is a chemical property or a physical property. A chemical property is the ability to undergo a specific chemical change. In other words, it means a change in the composition. Now, this word is going to be mentioned a lot, and so we have to know what composition means. Composition means what it is made up of. So that means when we see a chemical property, it's the ability to change what it's made up of. For example, flammability. If you have a piece of paper and you catch it on fire, it's no longer made up of the same elements. Reactivity, chemical stability, toxicity, acidity, corrosiveness, and the ability to rust are all examples of chemical properties. If we don't know what toxicity is, it just means is something poisonous or not. Acidity means is it an acid or a base? And then corrosiveness, is it able to eat through things? A physical property, on the other hand, is the quality or condition of a substance that can be observed or measured without, keyword without, changing the composition, which means that we can look at this and what the object is made up of does not change. For example, we can scratch a surface to tell its hardness and it's still going to be the same object. We can observe its color, we can see if it conducts electricity, and we can see if it's malleable or the ability to bend, and it's still that same object. Now, both chemical and physical properties are actually very beneficial for chemists and scientists because they help identify substances. And we're going to be doing this in a lab coming up where we look at physical properties of different things and we try to guess what object I gave you. For example, if I said I had a colorless substance that was found to boil at 100 degrees Celsius and melt at 0 degrees Celsius, we would probably say that it's water. Specifically, if we looked at this sheet, the sheet down here says water. We say that it's colorless, it boils at 0, or melts at 0 and boils at 100, so we can see that it is water. Or I could say it's a colorless substance and it boils at 78, but it's melted at negative 117 degrees Celsius. We know that's not going to be water, so we would have to look at a list of knowns and we'll figure out that it's ethanol. So if we find ethanol over here, we can see that it is melting at negative 117, boiling at 78. So one thing to note is that melting and boiling points are also considered physical properties. So if you don't have that written on your notes somewhere, please add that Melting and boiling point counts as physical properties. Now, physical properties can be further divided into whether it's extensive or intensive. So here's our properties of matter. We've already talked about chemical, we've already talked about physical. So now we're going to get into this idea of extensive, which here it says cannot be used to help identify substances, because we're going to find out that it changes, keyword here. Intensive can be used to help to identify substances because these do not change no matter how much matter is present. An extensive property is basically a property that depends on the amount of matter in a sample. So that's what makes these not as dependable, because they can change. For example, mass can change no matter if I have a small amount of a sample or a lot of a sample. Volume also changes as well. Length, height, and size will all change depending on the amount of sample that I have. Now, we're going to define two of those terms because they are SI units of measurements. The first one is mass. This is the measure of the amount of matter an object contains. For example, the mass of a basketball is going to be greater than the mass of a golf ball. So if we think about it, the more basketballs we have, the more mass. The more golf balls, the more mass as well. Volume is the other one as well. Volume is the measure of the space, keyword there, space, occupied by an object. So we can say that the volume of the basketball is greater than the volume of the golf ball because the basketball takes up more space. And this is an extensive property because if you have more basketballs, it's going to take up more space. So it does depend on the amount that you have. Intensive property, this is going to be a lot more beneficial at identifying substances because this depends on the type of matter you have and not the amount. Things like density is going to be a big one, color, boiling point, hardness, temperature, malleability, conductivity, and even the state of matter is going to be considered an intensive property. So we tend to look, we're going to have a lab coming up, we're going to look at density, we're going to look at color, and we're going to look at boiling point. We're also going to look at this idea of solubility as well. Now, depending on circumstances, one thing I want to cover is states of matter, because we learned that states of matter are going to be considered a physical property. And specifically, states of matter is actually considered an intensive property, which means we do not care about how much we have, it's going to be in this state. For example, with water, we can have water, ice, or steam. Sometimes steam is called water vapor. This type of compound exists in 3 different physical states, and so can a lot of other things. So what are the 3 states of matter? The 3 states of matter are going to be a solid, a liquid, and a gas. We're going to go through each of these individually and give you characteristics, starting off with solids. A solid is a form of matter that has a definite shape and volume. When I say the word definite, that means it does not change. And so we see that right here. The shape of the solid doesn't depend on the shape that the container's in, because that shape is not going to change. How much space that it takes up is not going to change. The other thing to note is that when we look at a solid, the atoms or the little tiny particles in a solid are packed very closely together. You can see down here, I don't really have a lot of space. They tend to be in a very orderly arrangement, and a lot of solids tend to be crystalline solids, which definitely have a very orderly, close together arrangement. Now, because atoms are packed so close together, they are said to be almost incompressible, which means that we cannot take a solid and squeeze it into a smaller volume. That's why we said that it has a definite volume, because the volume doesn't really change. Even when you heat a solid, they don't really expand like you think they would. They only expand very slightly. Liquids, on the other hand, are kind of the middleman. They have an indefinite shape. So indefinite means it changes, but a definite volume. And remember, definite means it does not change. So that means we're going to see that the liquid's shapes change, but how much space it takes up doesn't. And when we look at the atoms in a liquid, this isn't going to explain why we see that property. If we look at the particles, we're going to see that they're close together, but they can still have a little bit of space to move around. So they don't really have a rigid or orderly appearance. They tend to be flowy. Now, because they tend to be flowy, that is what allows them to have that indefinite shape. If we put a liquid here in an early matter flask, it's going to take the shape of a triangle. If we put it in a bowl, it's going to take the shape of the bowl. If we put it in a tall, slender glass, it's going to take the shape of the glass. However, the amount that we have, because they are still kind of close together, we still have that fixed volume that we see. Now, liquids are almost incompressible. Almost, because they are still close together. However, they still have a little space, so that little amount of space can be compressed. It's just not a big difference that we see. However, when we heat liquids, these tend to expand slightly when we heat them. And you can see if you've ever had a bottle of water in your car and it gets hot, it tends to kind of expand just a little bit. The last one we'll talk about is gases. Gas is a form of matter that takes both the shape and volume of its container. So we say it has indefinite shape and indefinite volume. So that means it changes. Gas is going to change the shape and volume based on its container. Now, the particles in a gas, the reason they're able to have indefinite shape and volume is because these particles are spread really, really far apart. And so there's a lot of room for those particles to move, and also there's a lot of room for those particles to expand and get compressed together. So like we said on the previous slide, these particles are pretty far apart, and because of the space between them, they can be easily compressed into smaller volumes. And we see this with gas. We compress helium gas into helium tanks to fill balloons. We compress oxygen into oxygen tanks to scuba dive. So we can see this gas get compressed into a container. The last thing we're going to leave off on is this word vapor versus gas. Now, sometimes people use these words interchangeably or for one another, but you can't really do that in a chemistry class because there is a difference. Now, gas and vapor means that they're in their gaseous state. However, we have to look at what is their state of matter at room temperature. If their state of matter at room temperature is a gas, we call it a gas. Things like oxygen, neon, helium, hydrogen, carbon dioxide, those are all gases at room temperature, so that's why we can call them gas. But things that are in its gaseous state, that are usually liquids or solids at room temperature, we call vapors. So for example, at room temperature, water is a liquid. However, you can heat water up to turn into steam or water vapor, and that's why we call it water vapor. Same thing with a lot of other things as well. We can heat them up and turn them into a vapor. And that is the end of today's lesson. If you have any questions, please make sure that you ask, and I hope you guys have a great day.